Hi, I'm Louisa.
And I'm Sonica.
And this is our project.
Our project is a dorm room sign which is embedded with a circuit controlled by an Arduino. It is also powered by a battery, and we are going to be using command strips to mount it.
The purpose of our project is to alert people whether or not the Pratt Star is in their dorm studying or out of their dorm saving the world.
As you see in this video, as the button is pressed, the lights alternate. So this is the inner workings of our project. There are 3 circuit boards, one with a push button and 2 with LEDs. So how our project works is when the button is pushed here, a signal gets taken in through this yellow wire to pin 2. Let's look at our code to find out what's actually going on. Before we continue, let me explain the code a little bit. There are essentially 2 sections of it. One is the setup and the other is the loop. What the setup does is it initializes pins to be either input or output, meaning is this pin going to read or write data? The next section is a loop, which is running continuously. So let's look at this more in depth. If the button is pushed, then we're going to switch the values of the LED. So for example, if the red LED was turned on initially, it's now going to be off. And if the green LED was turned off initially, it's now going to be turned on. This will cause the lights to alternate. One thing I want to point out really quickly is our debounce function over here. So what the debounce function does is it causes a slight delay so that multiple inputs aren't read by the push button, which is often caused by mechanical issues. So we cause this delay in reading just to make sure the computer doesn't think that we've pushed the button multiple times when we've only pushed it once. As seen in this circuit, which lacks a debounce function, getting a debounce function to work was critical in our project. Let's look at the circuit again. Say for example, pin 13 is high. A current would then flow through the green wire, through the resistor, to the LED and back to ground.
Now, to move on to actually designing the sign, we had to start asking a few questions. What did we want it to look like? How could we plan the circuit so that the spacing was correct? And how could someone change the battery when it ran out? And we planned what we wanted the board to look like on a whiteboard when we came up with this masterpiece. And to solve our spacing issue, we actually ended up soldering to 3 different boards that you see now. In our previous arrangement with only 1 board, the spacing just wasn't large enough to have us perform the functions that we wanted it to. And to answer our last problem, how could we change the battery when it ran out? Or how could we make sure that this just wasn't continuously powered so the LEDs burnt out? We added this little nifty shelf in the back of our board. So this battery right now, whenever it's plugged into here, it'll be powering the Arduino. In this way, with this little shelf and this insert, we can remove the battery at any time, and when it's plugged in, it's supported by our shelf.
And now our question to you is, are you out saving the world?